Hi. After we've seen the DMA scatter gather works, how it works and understood what it's expected to do, we can move to use the driver. We'll create a new project, direct it to the same XSA. We'll call it driver Scatter Gather DMA software, direct it to 0 ARM, and open an empty application. We'll create a new file in our new project. We'll call it driver Scatter Gather DMA software.c, and we'll start the driver. We don't need the simple. The includes are the same, so we copy that from the simple Scatter Gather DMA. We just don't need the BD size because we have it in the driver. And we'll copy the start of the main and the end of the main. Okay. Also, the first thing we need to do is generate the data. This will do this exactly the same way because it's not a part of the driver. We use the same function that we used in the simple. Now we need to start. First, we need to identify our DMA. For this, we need two structs. Structs are data containers holding predefined variables of the whatever we need. So the driver is defined. Here we use the xaxidma.h driver. This driver has two structs. One is the xaxidma config and one is the xaxidma. The config structs gather all the data of the DMA from the x parameters file. Here we have the data, the DMA. It has device ID, it has base address, it has its scatter gather or not, everything that we put in the design. So we need this struct to collect the parameters from the XSA, and we use a device ID to identify which DMA we are looking for. And then we have a struct for the AXI. This is the struct that we will build for this DMA that is instance in our design. It has again a few parameters, and it has another struct in it called xaxidma BD ring. This is the struct for the BD ring, for the TX and for the RX. The BD ring is also a construct for the BD ring, which has all the information for the BD ring, the first, the tile, the cyclic, and all those parameters. And it contains another struct called the xaxidma BD for a single BD. This struct is very simple. It's just 16 words of 32 bits. This is the BD that we use instead of generating by hand like we did in the simple. The first thing we do, we collect the parameters from the XSA to our config struct. Then we move those parameters of the config struct to our xaxidma struct. This parameter in the example design is usually defined above because the examples use functions and it wants to use this specific struct in all the functions, and they move it by pointer. I put it inside because it's easier to debug. This you can compare to the examples that I showed you and make whatever is comfortable for you. Next, we need to, like we did in the simple DMA, we need to start building the BD rings. For this, we need 2 pointers for the BD rings. One for the TX and one for the RX. And we need to get those pointers from our XSI Scatter Gather DMA struct that we're using. For this we have a macro which calls for the struct of the DMA and call for the TX BD ring pointer in this struct. The same for the RX. So we allocate those 2 pointers. And now we need to create them. We have a special function for this. xaxidma BD ring create. This is a function in the driver in the bdring.c file, which actually generate all the BD ring with the parameters we give it. For this structure we need the pointer for the BD ring, we need the physical address of the BD ring and the virtual address if we're using Linux. I'm using bare metal, so it's the same function. Then we need the size. We don't need the BD size that we had in the simple because the driver defined this parameter xaxidma BD minimum alignment as 40. It's just 40, but we have it in the driver, so we're using it. And how many BD rings? How many BD we have in the BD rings? For the TX and the same for the RX. Now we have our BD ring ready. We need to start building the BD rings. For this, like we had in the simple, we need a variable for the BD and we need a variable for the address of the data. So we'll define 2 pointers and 2 numbers. The pointer is for the BD inside the BD ring. Here is the BD ring and here is the pointer for the BD in the BD rings. And we just add a number which will contain the address of the data of the TX block and for the RX block. We start at the beginning of the data memory space for the TX and for the RX. Now we need to allocate the first BD in the BD ring. For this we have another function called xaxidma BD ring allocate, which gets the BD ring pointer, the number, and the BD pointer. So we get the BD ring for the TX, we need the number of BDs we have, and a pointer for our newly created BD pointer for the TX and for the RX. These are the 2 pointers that we will use in the loop. After we define the first addresses and pointers, we can go for our loop. Now the loop is quite the same, but we don't need all the 0 that we had in the simple. This was done in the creation of the BD ring. and we need to add the address. So we have a function of creating the address for the BD ring. We have the BD ring pointer and the address. This is why we need a variable for the TX buffer address. Next we will use the length. We have again the BD pointer, the length, and the max length. Now the max length is a parameter in the BD ring pointer. Here. This is actually defined by the hardware, the size of the data packet that we can use. This is actually a physical parameter of our DMA. So this is why we need it here, and we need to define the length, and we need to define control for the BD ring, for the TX BD ring. Now the control, I skipped this in the simple software, but here we need it. For every packet we send in the BD ring, Xilinx give us an option of using frame, of using at least 3 packets which we combine to a frame, which have a start of frame, an end of frame, and all the frame in between. So to mark a start of frame, we'll use in the control, we use the 8. If you see in the control here, this is the control register in the BD. It's not a register, it's in the memory space of the BD. So there is a start of frame and an end of frame. And if we want a frame, we use for the start of frame the 8, we use for the end of the frame 4. But since we are working with both, we can use C, which means it's both start of frame and end of frame, and it's a single packet which we want to transfer. So we define here that it's a single packet for this BD ring, and that's it for the TX. The RX, the same, but we don't need the control in the RX. We'll get the control that was sent from the TX in the RX status register in the BD ring after it ran. Next, we will increase the size, the address for the TX block by the packet length, and for the RX block in a packet length, and we have another macro to move us to the next BD in the BD ring for the TX and the RX, and we go on for the next BD in the TX and the RX, and so on until we have the full BD ring. And we must remember to flash it to the cache. Again, we use the parameter from the driver of how many bytes we have and the size of how many packets we have, how many BDs we have. Next, we need to work the DMA. The DMA here, we worked with the registers. Now we have functions for it. We have 2 functions. One is to gather all the information for this BD ring. Now I make the switch. I start with the RX and move to the TX. So we define the BD ring pointer with the number of BDs and the pointer for the start of the BD ring. For the RX and for the TX, this function calculates the last BD in the BD ring, so we have all the information ready to start a transaction. And then we use start. Start, take the BD ring and just start it. This actually writes to the hardware. This function actually writes to the hardware. If we use the other way around, if we use the start first, it won't have the parameters of the last BD. So it only storage the first 2 parameter, which BD to start and to enable the DMA. And when this function comes, bring to hardware, it will add the last parameter which will start the DMA. But if I use this after making the start, we'll have the whole function together. We'll have the start BD, the enable, and the last BD, and then we'll start. Now we need to wait for the BD, for the DMA to finish. For this we have another function that actually, since this function is both for the scatter gather and for the simple DMA, and because it's from the DMA, it's the control register in the DMA, and it's check if it's idle for the BD ring we tested. So here we use the main parameter for the DMA, and we use data to device. Data to device is the TX, and device to data is the other way around, the RX. So first we look if the TX is finished its job, and if it's finished its job, we look at the RX if it's finished its job. Once they both finished its job, the DMA finished its job, and we can move to check the data. For this we have again the invalid the cache, and we use the addresses, the memory spaces that we provide in the beginning for the BD space for the TX and the RX, and for the TX and the RX data. And actually that's it. That's the software. Now I'll save this, I'll compile this, I'll connect my board, and we can run it. But since we have two programs here, we'll launch debug. But since we ran the simple, we need to make sure that now we're running the driver. Again here, it's the driver, and we can start the debug. Okay, we have the same memory location that we had before. The data is always garbage because I closed my board. And we can start working the driver. The first thing we do, generate the data. We go to the TX buffer, and we stop here. And we have the data like we have in the simple example of the scatter gather. Now we read the config struct from our X parameters, and we had all the data from the X parameters file, and we initialize the DMA and start the xaxidma struct, and this actually goes to the hardware and generate a reset here. Now we allocate the TX BD ring and the RX BD ring in the structs, and we generate the TX BD ring and the RX BD ring. So here's the TX BD ring. Now we see that the create function automatically gave us all the addresses for the BD ring. All the addresses are ready. We just need to fill the length and the control, and we're good to go. The last BD ring here is pointing to the first one. This is used for cyclic. Here it doesn't really matter. Now we generate the RX BD ring, and now we have to fill the BD ring. So we have here the 2 pointers for the BD in the BD rings, and we have the 2 numbers of the data of the TX and the RX where the data is stored. Now we allocate the BD in the BD ring. Here the TX went to 1000, the first BD in the TX BD ring, and this one went to for the first BD in the RX BD ring. Now we can start filling up the BD, the first BD in our loop. So we use the address here 2000, the first packet in the TX buffer. We use the length 20 for the packet length, and the control C. The same for the RX. Address, length, we don't need the control, but this will come in the status register. Now we move to the next TX block, the next RX block, the next BD ring for the TX, the next BD ring for the RX, and we can do it all over again. I'll skip this and run to the end of the writing of the hardware. And here we have all the BD rings ready in the TX and in the RX. So now we just need to run the DMA. All the data is ready. For this I will use my ILA. And we'll run the full function like we did in the simple Scatter Gather DMA. And it's done. And we can see here all the transactions to the Scatter Gather DMA. Here we see the configuration of the RX. The first BD ring, the enable, and the last BD ring. In this place the RX is ready, but the TX didn't generate any data yet. So we generate the first BD for the TX, the enable, and the last one, and the DMA start working, and the data is coming out and gathered in. And we're reading the busy register. Now we see all the time it's 1.8. Remember, we need the 2 here to stop the BD, to stop the transaction. So everything is 1.8 until the end of the transaction, which is here. And here we have again 1.8, 1.8, 1A. This is the TX. The TX has finished, but we're still counting for the RX. It didn't finish. Now both of them are A, so we finish the transaction. And the last thing we need to do is invalidate the cache. So now we invalidate the TX BD ring, and we see the 8 here, just the 8, all the places. For the RX we get 8C because we got the control from the TX. The C that was in the TX here, the control, it's now moved and we know it in the RX. The TX buffer didn't change, and the RX buffer has now the data as the TX. This is how it's done in software using the driver. You can select whatever comfortable for you. If you're a hardware guy, you might want the register, it's easier. If you're a software guy and planning to move to Linux, You might use the driver itself. The examples, like I showed you in the beginning, that we have examples in the installation of the Vitis. In Xilinx, Vitis, version, data, embedded software, processor libs, driver, the DMA, and examples. And if we look at those, we start with the polling. Here, you'll see that you have all those functions here. There are many more functions here, which they make a little too complicated for my taste. So I shrink the main function that you need. They have so many more, but I hope this will be clearer after this video. So this is the Scatter Gather DMA. I hope you find this video useful. Thank you and goodbye.